concept of the unit circle, and it gives rise to sine, cos and tan of different angles. It's a very important concept, and I'll spend a little bit of time here explaining how it works. If we have, as we said, a unit circle. Now, a unit circle is nothing more than a circle with a radius of 1. So we've got our x and our y, and it has a radius of 1. Now, P is a point that sits on the circumference, and we'll let it have the coordinates x, y. So it is x units out. So if I drop a perpendicular down here, that will be right angles. The length from there to there will be x units, and the length from there to there will be y units. Now, we've already said that it is a unit circle, so it has a radius of 1, so the hypotenuse of that triangle there is 1. Now, theta is an angle that starts here at the x-axis, so if theta had 0 degrees, well, P would be the point down there. So we'll let P have an angle of theta. So P has moved from there up to there, so it has gone through theta degrees or theta radians, depending on what you're working in. So from this right angle triangle here, we know that sine of theta, sine is opposite over hypotenuse. Now the opposite is y, so it'll be y over 1. So it'll be nothing more than the y coordinate of point P. The cos of theta in this right angle triangle here is adjacent over hypotenuse, so it'll be x over 1. So anything over 1 is just whatever's in the numerator, so that's just equal to x. And the tan of theta is opposite over adjacent, so it'll be y over x. Now, we've already set up here that y is equal to sine theta, and we've said that x is equal to cos theta. So tan of theta is equal to the sine of theta divided by the cos of theta. So as you can see, P is going to have a positive x and positive y. So we number our quadrants here. This is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. So in the first quadrant, you can see we get quadrant from a quarter of the circle. So in the first quadrant, everywhere up here, sine, cos, and tan are all positive. Now in the first quadrant, theta lies between 0, can be equal to 0, and 90 degrees. And if we're working in radian mode, it'll be 0 less than or equal to theta less than or equal to pi on 2, 90 degrees pi on 2. Alright, so that's in the first quadrant. What happens when we go into the second quadrant? So let's just use another colour. If we worked off the x-axis and we went up theta, and I drop another perpendicular down here. Now, because of symmetry, and you can have a look at this, this is still 1. This will also be, this will be P1. The y coordinate will be the same. Now the x coordinate, it won't be x because that means a positive value, so this will be minus x. So that, or that point there will be negative x. It'll be x units long, but the x coordinate will be minus x. So that is still x units long, but it's out in the negative direction. So the coordinate, the x coordinate of P1 will be minus x. So if we've got an angle that is in the second quadrant, so if you like, we always measure starting here, so this will be 180 minus theta to get back to that. So this angle here, from 0 around to there, is 180 minus theta. So the sine now we said sine is just the y coordinate, so that'll be just equal to y. So the y coordinate up there, just y, and that is equal to sine of theta. So that is an important identity. Sine of 180 minus theta equals sine of theta. The cos of 180 minus theta, now 180 minus theta is all the way there back. And we've said that the cos is just equal to the x value. Now the x value will be negative x. So that's equal to negative cos theta. And the tan of 180 minus theta is equal to the sine value, which is y, over negative x. Now y over negative x is negative tan theta. And so on. We can move around the circle, and here we'll have, so this is angles in here are 180 minus theta, angles here are 180 plus theta, and here we can go 360 minus theta, or just minus theta will bring us into the fourth quadrant. So we can continue on. So this is in the second quadrant. We've got all of those in the second quadrant. So in the second quadrant, sine is positive. I'll use that abbreviation for positive, and cos and tan are negative. So sine's positive in the second, cos and tan are negative. Continuing on around this, and I'm not going to do all this for all four quadrants, but in the third quadrant, sine and cos are negative, tan's positive. And in the fourth quadrant, sine and tan are negative, and cos is positive. Now, you don't have to work all those out. When we've got the unit circle, we can simply use the acronym CAST, and we put the C down there, the A up there, the S up there, and the T there. And CAS, this is all, this is sine positive. So these are the angles that are positive. And then we've got tan positive, and we've got cos positive. So if we wanted, say, the sine of 330 degrees, 330 degrees, we know this is 0, this is 90, this is 180, this is 270, so 330 degrees is in this quadrant. Now we work off the x-axis, so it'll be equal to the sine of 360, 360 being the x-axis, minus 30. 360 minus 30 is 330. So now we look at it and we say, righto, in this quadrant, which is the fourth quadrant, sine is going to be negative because cos is positive. It's the only one that's positive. Sine will be negative, so we can put a negative we write the word sine, and we just put this angle here. We forget that sine, we forget the 360 and just put sine 30. We then go and say, oh, 30, I've seen that before. That's that little triangle that's got a 30 up there, 60 down there, and 1, 2, root 3, one that you need to commit to memory. Sine of 30 is opposite over hypotenuse, so that's minus. Sine of 30 is equal to a half. Alright, so you need to be able to work in all four quadrants, so you can have sine, cos and tan of any size angle. And you need to remember CAST, you need to remember the unit circle, and this is most important that you remember the sine is equal to the y, cos is equal to the x, the tan is equal to y over x, which is sine over cos.